Good morning, dear students. Today will be your professor of algorithmic analysis. My name is Andres Alexander Silva, and my partner Esteban Arias Peláez will talk about the importance of algorithmic analysis. Where of the term algorithmic analysis. Algorithmic analysis refers to the study of the efficiency and performance of computer algorithms. In emerged as computers become more widely available and used for a variety of applications, which highlighted the importance of choosing and designing efficient algorithms. In the late and 1950s and early 1960s, formal methods of analyzing algorithms were developed, and influential figures such as Donald E. Young contribute significantly to this process, with the establishment of computer science as an academic discipline in the 1960s and 1970s. Algorithmic analysis becomes an essential component of computer science education. The computer programming as art and science. Computer programming can be considered a combination of art and science. Programmers can express their creativity with solving problems and writing elegant code, but they must also apply mathematical and scientific rigor to ensure the functional and efficiency of their program. This perspective highlights the duality of programming as a discipline that combines elements of creativity and logic. Donald Knack processed their characteristics for programming as an art and as a science. For art will be creative aesthetic of code individual styles, and for science they will be mathematical rigor, optimization and efficiency, precision and accuracy. Ideal language for software developer. Importantly, Nong's perspective on the ideal programming language reflects his emphasis on both the artistic and scientific aspects of programming. He values clarity, efficiency, and expressiveness, emphasizes the need for a balance between human-centered feature and machine-level control. The main features are human-oriented, efficient, expressive, reliable, portable, and minimalistic. Testing and programming styles. Testing and programming styles are essential aspects of computer programming as both an art and a science. Testing is essential to ensure that a program works correctly and meets to the established requirements. A neat and consistent programming style not only makes it easier for other programmers to understand the code, but can also be considered an aspect.
Good morning, my name is Esteban, and I will be explaining the second part of the video. Why do we study algorithms and their analysis? Okay, so far we've talked about some basics, but we haven't gotten into the real questions yet. Well, why do we study algorithms? The answer is quite simple. An efficient algorithm design is something vital for solving problems in the best way possible. As for why should we perform an algorithm analysis, again, the answer is rather simple. Which one do you prefer? An efficient algorithm that fits your needs and it's going to give you a better performance, or something that will just do the trick? By analyzing them, we can have a better understanding on how they work, and how they can be improved. In this example, we can see two bicycles. Both of them offer the same result, point A to point B. But if you have to choose between the best way to travel from point A to point B, which one will you choose? Now, you should know your tools. Why you should know algorithms? For us, it's a game changer to know and to understand all the different types of algorithms so we can use them accordingly to the situation. For instance, let's say you have a list of a lot of ordered numbers. Yeah? If you use binary search instead of linear search, you will find that the binary search is way more optimal than the linear search because of how it works. Some real life applications for this can be optimization, finance for risk assessment, fraud detection, frequent trading, games. Yes, if you want to have good performance in your game, eventually you will have to resort to more efficient ways to code. Now, in the little graphic, you can see the binary search and states binary search will prove more efficient than a linear search when the conditions are met. That condition is the data needs to be sorted. On the other hand, if the data is not sorted, then just use your average linear search algorithm and it will be just fine. Now, what is it? What is it the algorithm analysis? Okay, we have here the fundamental purpose of an algorithm evaluation is to decide how much time and space an algorithm needs to solve the problem as a feature of the scale of the input. This basically tells us algorithm analysis makes reference to the process of investigating the effectiveness of an algorithm in terms of time and space complexity. Now we have some advantages of using algorithm analysis. If we actually take the time to study an algorithm, we might find that it can be improved in certain ways. This improvement can be in terms of efficiency, scalability, or it can be simply just by enhancing our own knowledge. Such improvements are crucial in gaining competitive advantages. And who knows, maybe you will be the next person to create a well-known algorithm. So, in conclusion, algorithm analysis, focusing on the efficiency of computer algorithms, emerged by the proliferation of computers. It became a fundamental component of computer science education. Computer programming is seen as a combination of art and science, where programmers balance creativity with scientific precision. As for why is it relevant, you should know the best possible way to solve a problem according to its context in order to deliver the best possible result. Thanks for your attention.